today. I'm new to this course of action. That's why I want to introduce myself at first, and then talk a bit about the organization in the lab. So the organization of SMMs comes first. I just want to give a short introduction of me. I did my bachelor's in Heidelberg, my master's and my PhD studies here. So thank you at this point for Annie for having me here. And I had 2 research stays abroad. And I want to start talking about a bit about my research, which is on SMMs, or to be more precise, on Lanthanide SMMs. These, or as you heard earlier, SMMs have the property that they follow an external field with some delay. For Lanthanides, as Annie explained earlier, you have different shapes of the ground states, and if you put them in electrostatic free from the ligands, you could stabilize or destabilize magnetic states. This leads to an energy barrier. However, for Lanthanides SMMs, it's very common that they don't do their relaxation over the barrier, but have under barrier processes. And in order to understand them better, you need some, or it is handy to have some standard molecules that you can vary in certain parts and pieces in order to exclude for too many influences on your molecule and your relaxation processes. And for this, I created a testbed system with literature known ligand, and varied the terminal ligands on that system, and created a whole family of monomers and a whole family of dimers. And these show to have really nice properties, which could be related to or where we could see packing effects with different counter ions on the magnetism, which we have published in a very recent paper, which just got accepted. And in collaboration with Kaiserslautern, the Schünemann group there, we made some dysprosium 161 complexes that were investigated with a new technique in order to find out what spin-phonon coupling does on the relaxation on these compounds. But the major part I want to talk about is the organization in the lab, as this might be the most interesting for you. We had a big problem here at our institute because this is under construction or renovation. And this group lost a lot of lab space, which meant, which you can see here, we went down from a lot of floors to just 2 double labs, which is a loss of 2/3 of the lab and storage space. And you probably know how labs usually look like. You have a lot of things which you usually use for accumulating a lot of knowledge, but if you somehow need to downsize, that can be a problem. And as you probably know, there are some rules that we have to obey to store especially chemicals. But additionally, so we have the safety aspects, but additionally, we have usually a lot of materials or small devices lying around. And with the materials, it can be that people don't know where to find them, or small devices which are rarely used sometimes get forgotten about. The usual thing you would do is to put everything into a list, right? I think that's what most people have. And that has some caveats, and these are the accessibility. Sometimes it's just a PDF list being on some server, and yeah, only some have the possibility to change that. Sometimes you have problems to find something on the list, and if we ask us the question if it's all up to date, yeah, maybe not always. So I thought about, could we maybe find a better solution? So I did some research on the internet, and there's a very nice program on the internet, Lab Suite, and that helps a lot with organizing your lab and lab space. So what the program does, especially for the storage of chemicals, is you can add all your chemicals and sort them by location and by people that are using them. So that's the main thing we use it for. And that's quite easily doable. You can put in a CAS number for a new chemical item, and then it creates the chemical structure and the name of the chemical. You can add a lot of additional information about the item. So in Germany, we have to also have in these lists how much of it we have in stock. So this is stored here. You can put an owner in or somebody who's currently using the thing. And the most important is you put the location in, so people who would be searching for it can easily find it. It's not only possible to do this for chemicals, you can also do this for other materials. The next thing, which is quite handy and we're using, is the request part. There, people from the group can put things in they need, and Annie can accept that or approve these requests at a later point just from her desk. So this is how it looks like. If you want to create a new request, you can put in supplier, item name, pack size, but also some information about the costs. Or if you have personnel that is actually doing the order, then you could put some comments in, like, for example, where the people who would like to use it found the item, or if it's needed to purchase it from a special place because of whatever impurities not disturbing the reaction. You can do the management of the people who can access the thing, and you can give them different rights. You can also, which we don't do for now, manage financial thing and purchase thing about it or through it. What we did additionally was to create QR codes for different storage places, and what we want to do is create QR codes for every single item, so that every digital item is linked to real life item, or the other way around. This means ideally that you can go to the lab, scan the QR code, and if you want to use a chemical, for example, change the amount after you used it, or if you want to use it at another place than it is actually stored, then you can change the location of the thing. Good. I prepared some examples for these QR codes and testing possibility for this lab suite. If somebody is interested here in person, then they can try that out. Unfortunately, I don't have the possibility for people listening from at home. Okay, so I want to thank you, Annie, for having me, and the whole group for the great work here. And I want to thank all the people or the organizations supporting me financially. And with everything. So thank you very much.